Okay, so today we're going over 4.2/4.3. They're very similar, so I kind of just put them together instead of separating them, especially since this is something you learned last year in Algebra 2 and it's just review. So what does it mean to be a factor? So remember, 4 is a factor of 20 because when we divide by 4 we get 5 and there's no remainder. So when you need to determine whether A is a factor, we're going to divide and check to see if there is a remainder. That leads us to the remainder and factor theorem. So we have two different methods that we can use when we want to figure out if something is a factor. So for example, it says, is x minus 2 a factor of the function f of x equals 2x squared plus 3x minus 8. Okay, so the first method is doing synthetic division. So we're going to use synthetic division with the 0 of x minus 2. So the 0 of x minus 2 would be positive 2. And then we're going to use our numbers from our function. So 2, 3, and negative 8. And then we'll complete synthetic division. So once again, you did learn this last year in Algebra 2. This is just a review. Remember, we pull down the 2, and then anything under the line we multiply. So 2 times 2 gives us 4. Add down, multiply, add down gives us 6. So this number is always our remainder. So because the remainder is 6, that means that this is not a factor. Because remember, it is only a factor if there's no remainder. And so since we have a remainder, it is not a factor. Okay, so that's method 1. Method 2 is to plug in the 0 and see if the answer is 0. So if I plug in the 0 here of x minus 2, which would be positive 2, into all of the x's. So f of 2 would be 2 times 2 squared plus 3 times 2 minus 8 would give us 8 plus 6 minus 8 gives us 6. So the remainder is 6, which means it is not a factor. So as you can see, both of these methods work. We both got a remainder of 6 both ways. It really doesn't matter to me which method you use. It is totally up to you. So I would like you to pause the video and try these 3 examples here. We're going to see if x plus 1 is a remainder, if x minus 3 is a remainder, and if x plus 3 is a remainder. So at this point you should have done all 3 of the problems. So here is my work. For negative 1, it's not a factor. 3 is a factor. Negative 3 is not a factor. Now, if we reread the directions, it does say if it is a factor, write your polynomial as a set of factors. So because in part B we said yes to write our function as a set of factors, x minus 3 is a factor. The other factor comes from this guy, the 2x and the minus 5. So if this function was an x squared, when we divide, it goes down an exponent, so this becomes x. So our other factor is 2x minus 5. Now, if I were to distribute this out, I would get this as an answer, okay, if I were to distribute this out. Now, just be careful. Remember from Algebra 2 last year that if we have any missing terms, it must have a placeholder of 0. So for example, our 0 here of x minus 2 would be positive 2. Now we have 3x squared, or x cubed, but we don't have an x squared, so we have to have a 0, then 2x, and then negative 7. So just don't forget that when we are missing a term, we have to have a 0 in place of it. Okay, the next theorem we're going to talk about is called the rational root theorem. So the rational root theorem says find all the rational zeros of this function. So in order to do that, we need to use synthetic division over and over and over again until we found all the numbers that have a remainder of 0. Okay, well that could take forever. So how do we know where to start? We know where to start by doing the rational root theorem which is P over Q. And that's what we're going to talk about in just a second. And how do we know when we're done? How do we know when we found them all? Now remember, the number of zeros is equal to the highest degree. So in this case, our highest degree is x to the third. So we would have 3 total zeros. Okay, so what is the rational root theorem so that we know where to start? So the rational root theorem says that if we have a polynomial, we could list all the possible rational roots, not all of the answers, just all the possible rational roots, which can be found by doing P divided by Q. Now P is the factor of the constant, this guy, and Q is the factor of the leading coefficient, which is this guy. Okay, so for example, let's go back to this problem. It's down here again. It says find all the rational zeros. So the first thing we're going to do, right, because up here we said the first thing that we're going to do is do the rational root theorem, is we're going to find all of the possibles by doing P over Q. Now if you remember, P comes from our constant, so that would be 8, over our leading coefficient, which is 3. Now it's not that our answer is 8/3. We're now going to list all the factors of 8 and all the factors of 3. So 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. 3, we only have 1 and 3. Now I'm using positive and negatives here because if we had 2 negatives, that would still give us a positive, etc. Right? So we have to have all of our options here. And then roots can also be negative. We could have a negative over a positive or a positive over a negative. So here's all of our possibilities. So now we're going to write them as fractions. So we're going to kind of go through each case. So 1 could be 1 over 1, which would give us 1. Then we could have 1 over 3, which would give us 1/3. Then we could have the 2, so 2 over 1, which would give us 2. And then 2 over 3, which would give us 2/3. Then we're going to move on to the 4. 4 over 1 would give us 4. 4 over 3 would give us 4/3. 8 over 1 would give us 8. 8 over 3 would give us 8/3. Okay, so these are all of our possible answers. Okay, how many total answers are we going to have? Well, because our degree is 3, we're going to have 1, 2, 3 total answers. Okay, so now we want to figure out which of these is our answers. So what we're going to do is we're going to go to our calculator and we're going to start trying some. So we're going to go to our calculator, we're going to plot our function. So 3x to the third power minus 13x squared. What am I doing? Oh boy, I gotta start over. Sorry, guys. Okay, now we're gonna go to our table set. So I'm gonna go second table set. And I'm gonna have the table just start at 0. I had a weird number. Yours is probably 0. What I want to do is I want the independent to be on ask instead of auto. So what is that going to do? If it's auto, when I press table, all of the table is going to pop up. If I change it to ask, I'm going to be able to type in the x values and the y values are automatically going to be put in there. So we're going to type in our x's, our y's are going to be automatic. So I'm going to go to my table now, so second graph, and I'm going to start typing in some of these. So 1. Oh look, because when I typed in 1, I got a y value of 0, that means it's a 0. So 1 is one of my answers. Boom. Okay, now let's try -1. That didn't work. Now let's try -1/3. That didn't work. What about +1/3? Right, and we're going to go through and we're going to find all of these. Now it would be kind of annoying. So I just typed in -2/3, so that one worked. And then 4 worked. So I got all of my answers by going through all of my possible answers. Okay, I didn't even get to all of these. Now, that is kind of annoying to type all of them in because what if these didn't work? Okay, so if we get one answer, we could kind of bypass doing this step by using synthetic division. So let's pretend we didn't get these two answers from using our calculator. What we could have done is we could have said, okay, well, I know one is an answer, so I'm going to use synthetic division. Pull down the 3, multiply, add, multiply, add, multiply, add. Now, if you don't get 0 in this step, something went wrong somewhere. Okay, if it's a 0, we should get a remainder of 0. Okay, so what does this mean? Well, this was originally an x squared or x cubed, which means this is an x squared, which means this is x. So our function is 3x squared minus 10x minus 8. So once we get to a quadratic, once we use synthetic division to get to a quadratic, we're either going to factor or use the quadratic formula. So let's see if we could factor. So we're going to see, do we have, it's multiplying to negative 24 and adding to negative 10. So that would be negative 12 and 2. Then we divide by our a term, which is 3. So we get negative 4 and 2/3. Now remember, those are just our factors. So x minus 4 and then 3x plus 2. Now if I set each of those equal to 0, we get x is 4 and x is negative 2/3. Which, if you look over here, those was our two answers. So if your calculator can find it, obviously you do not need to show your work. So if I gave you this problem on the test, you could right away just plug all of this into your calculator, get your 3 answers, move on. Okay, but sometimes that's not going to happen, and this is the process that we would do in case we couldn't find all of our answers. So let's look at number 2. So in number 2, we have x cubed plus 6x squared minus 13x minus 6. So we're going to start by doing p over q. So that would be 6 over 1. This is a 1 here. So all the possibilities of 6 are 1, 2, 3, and 6. All the possibilities of 1 is just 1. Anything divided by 1 is just itself. So these are all of our possibles. How many answers are we going to have? Well, we have an exponent of 3, so we're going to have 1, 2, 3 answers. Once we get 3 answers, we're nowhere in the clear. So now we're going to go to our calculators. We're going to go to y equals and we're going to plug in our function. And we're going to start plugging in our numbers. So we're going to plug in 1, that didn't work, negative 1, that didn't work, 2, 2 worked, negative 2, that didn't work, 3, negative 3, 6, negative 6. Okay, so I tried all of my options, and in this problem, the only answer I got was 2. So unlike our last problem where I was able to find all of the answers, in this problem, I can only find the 2. So now I'm going to go to my synthetic division with my answer of 2. So we've got 1, 6, negative 13, negative 6. Bring down the 1, multiply. Now remember, if you don't get a 0 here, something went wrong. Go find your mistake somewhere. So because this was an x cubed, this is an x squared. So we've got x squared plus 8x plus 3. Okay, now ask yourself, can that factor? Something multiply to 3 and add to 8? Well, nope, that can't factor. So because it can't factor, we have to do our favorite thing, the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 8 plus or minus the square root of, what do we got, 64 minus 12 would give us 52 all over 2. Now, of course, we always have to double check if our 52 can simplify. So 52 could be 4 and 13. So that will become 2 root 13, so negative 8 plus or minus 2 root 13 all over 2, which then, if we wrote that separately, we would have negative 8 over 2 plus or minus 2 root 13 over 2. So these 2's can cancel. This becomes 4. So we have negative 4 plus root 13 and negative 4 minus root 13. Now we have 1, 2, 3 of our answers. So I'm going to leave number 3 for you guys to try on your own and check your answers on the answer key. I'm going to go down to number 4. So on number 4, the first thing we have to do is P over Q, our rational root theorem. So that would be 6 over 2. So all of our possible for 6. And all of our possibles for 2. And we got to simplify. 1 over 1 would give us 1. 1/2. 2. Now 2 over 2 would give us 1, and we already wrote that down, so we don't need to write it again. Then we got 3. 3 over 2. And then 6. And then 6 over 2 would give us 3, which we already have. So here's all of our possibles. Now, because this is an x to the 4th, we're going to have 4 total answers. So whenever we have 4 answers, we're going to need to at least find 2 answers on our calculator so that we can do synthetic division twice to get this down to an x squared so that we could do quadratic formula if we have to. So I need to find at least 2 of these to work. So 2x to the 4th. We'll go to our table and we'll start trying some. So 1, negative 1, 1/2. 1/2 worked. Let's try negative 1/2. Negative 3 worked. Okay, so now that I got 2 of them, I have enough that I can start doing synthetic division. So let's do negative 3 first. So negative 3. Now remember, if you don't get 0, something went wrong. Now we're going to take this and we're going to divide the 1/2. So now we're going to do the 1/2 with our new answers. So bring down the 2, 1/2 of 2 is 1, 1/2 of 0 is 0, 1/2 of 4 is 2. Oh look, we got 0 again, that's a good thing. So keep in mind, this was x to the 4th, so when we divided, we got x cubed, then we divided again, now we're at an x squared. So we've got 2x squared plus 0x plus 4. Which is really just the same thing as 2x squared plus 4. Now, we can't factor this, okay? And we could do quadratic formula, but we actually have an easier way to solve this one if we just set it equal to 0. So if I set this equal to 0, I could subtract the 4 from each side. That gives me 2x squared equals negative 4. Divide by the 2. We get x squared equals negative 2. Then we can square root each side. Well, if you remember from Algebra 2, whenever we have a negative on the inside of our square root, that means we're going to have an I in our answer. The square root of 2 can't simplify, so we've got the square root of 2i, and then plus or minus, because whenever we take the square root, we can't forget plus or minus. So our last 2 answers are positive I root 2 and negative I root 2. Now we have all 4 of our answers. Okay, so I would like you guys to try 3, 5, 6 and 7 on your own and then check your answers on Canvas, I'm going to jump down to the intermediate value theorem or the locator theorem. So the locator theorem says that if we want to know if there's a root between two numbers. So essentially what we're saying is a root, remember, is a 0. So the intermediate value theorem says if we plug in -2 and -1, we want to know if they have opposite signs. So what's happening is we're going to start by plugging in -2. So I'm going to plug -2 into the function. We get -4. So what that's saying is that the ordered pair is -2, -4, right? So if we were to plot that, we've got -2, -4. This guy right here. Now let's plug in -1. So f of -1, you know what to do, right? I'm not going to write it all out, save us some time. We get 12. So what that is saying is at -1, the y value is at 12. So at -1, the y value is at 12. So because this is a negative number and this is a positive number, if I go from -2 to 1, I have to cross the axis here. So that's saying that somewhere between -2 and -1, there is a 0 / root, right? Root means the same thing. So somewhere between -2 and -1, it could be at -1.5, it crosses the x-axis. So somewhere between there, if I wanted to find all of our answers, our 4 answers for this, one of our answers is going to be between -2 and -1, whatever that may be.